This is our last week before spring break. Hey, which also bites because we've only covered 7 weeks. When we come back, will be the 8th week, and then there's the whole second half of the semester. Typically, spring break is in the middle. You have 8 weeks, 8 weeks. Now it's going to be 7 weeks, 9 weeks. So that's the only drawback. All right, let's look at what we talked about here last time. When we add these, yes, remember, you can't think of the way that you add now. What you have to do is you have to think about how to make it the best way the students can see it. First off, before we jump into partial sums, we talked about an expanded version. In other words, how would we expand this number? This number is actually what? 500 plus 8. And this 700 plus 50 plus 7. Now, how do you write 100? That's 5 times 10 to the second. 60 is 6 times 10. Remember, the number by itself, it has an exponent of 1. So any number has an exponent of 1. That's why this one has 2 zeros, so I put a 2 on top of it. And then it's just 8. So this one is 7 times 10 to the second. 5 times 10 plus 7. Remember, we also had to make sure we teach the students the rules of mathematics and how we move things around. What's that? What rule, what property can we use to move things around? See, you can't look at your notes when you're teaching your students. But go ahead and look at it. Look at it. What's that? Which word means to move? How did you get here? What did you do? Commute. It's the commutative property. Since there's a bunch of addition, it's the commutative property of addition, which means I can move these numbers around. So, and then we also talk about a concept of like terms. These two have 10 to the second. So we have 5 times 10 to the second plus 7 times 10 to the second. So these two are the same. Now I can look at everything that has just a 10. So we have 6 times 10 and then 5 times 10. And then whatever's left should be the ones. Another property we're going to remember we talked about last time. What property can we use to combine or to separate these? The distributive property. Remember, distributive property said this: a times x plus y is ax plus ay. We can go either direction. We're actually using the factor part of it. Since these two both have 10 to the second, if I take out the 10 to the seconds, what do I have left? 5 plus 7. That's how factoring distributivity works. This next one, they both have a 10 in common. So if I take out the 10s, I got a 6 plus 5. And then the last one is just the ones. Seven plus 5 is? 6 plus 5 is 10, and then 8 plus 5 is 15. Now we explode the numbers back up. What does 10 to the second mean? 10 times 10 is 100. Then we have 11 times 10. And then we have 15. The reason we do this, because when you multiply by tens, it's super easy. Because there's a 1 right there, 1 times anything is what? Itself. So this is 12, and you put 2 zeros behind it. The next one is 11 with 1 0 behind it. And then 15. Look at this first column. This is the same as this number. So typically we look at the first column, that's 5. So it's 0 plus 5 is a 5. Then look at the second numbers. 1 plus, these are all pluses. 1 plus 1 is 2. Same thing here. 0 plus 1 is 2. The third column, 2 plus 1. 2 plus 1. And then the fourth number, which is the biggest one. Now, why do I want to start with this? Because later on in mathematics, in algebra, you start spreading out the different types of numbers that deal with combining like terms. For example, these numbers here, what if we had the equation you were asked to combine these two polynomials? How would you do it? Because if you think about it, these coefficients, these numbers, same as that. This is what's really happening is we're spreading them out. We're teaching the students how to further apply these concepts. So this one is different than this one. Why? Because the terms are different. This one back here was 10 to the second. This one was 10. This is x to the second x. So how do you combine these? Well, let's look at how we have 5 plus 7x squares. That's those two. Then we have 6 plus 5 x's. That's those. And then we have the single numbers, no terms, no variables. 5 plus 7 is 12 x squared, 11x plus 15. Can we combine them any further? No, because they're not like terms anymore. But this is another step you get to in algebra. Actually, to be honest with you, this is chapter 3 in a college algebra course. And think about it, you're teaching them these concepts in elementary school. So you prepare them for what they're going to see later on. It's not that difficult. Matter of fact, I could have sat down first day of class in this room and taught you calculus. And it would have been such an easy way that all it is multiplying, dividing, add, subtracting. That's all it is. And you would have learned calculus. All right, so that's an example where we left off. What are partial sums? By partial sums, means we are working with one place value at a time. Isn't that what we just did? We took the tens column, the hundreds column, and the ones column. Those are the place values. The place values are the columns, are the ones, the tens, the hundreds. Those are the place values. We add them up, and think about it. When we add up the 8 plus 7 in the first column, when we did the 8 plus 7, that's the ones. That came up with 15. Is that the total answer? No. If you think about it, down here, these are the parts of the partial sums. So we have different parts and we put them together and we get one final answer. That's what partial sums are all about. Now, is there a right way or wrong way? Okay, here's one thing I need you guys to be very careful about when you become teachers. I know I've had students come to me and says, no, we were told we had to do it this way. And you were graded if you did it another way. Actually, the school districts force teachers to teach one particular way. Do not do that. Because the basic rules of mathematics is there is no one way of doing anything. And students may come up with ideas on their own on how to do it best way for them. Whatever works for them, let it work for them. I'm even saying that if they have to take off their shoes and use their toes, let them do it. Eventually, they'll build the skill set they need. Not everybody learns the same rate and the same way. So that's one thing that you have to be very careful about. I mean, you as teachers will be first one to complain if they're saying that you have to teach it this way. The reason they do that is because they go to some conference over the summer and they heard one presentation and they say, well, I have to earn my 6-digit salary, so I'm going to buy that and make everybody use it. So I did something I could put in my resume. What happens at the end of that year? That gets thrown away and goes back to the basics. So you'll be faced with that all the time as teachers. All right. There are different types of partial sums. Like, let me use the numbers here. What? 568 plus 757. We'll do it two ways. This way we'll go left to right. This way we'll go right to left. Which way is the most easiest for students to remember? How do they read? Read left to right. So when you first introduce it to them, they're going to read these things the same way. But again, it doesn't matter if whatever's easiest for the students, that's why I show them both ways. Partial sums. These are the what column? That's the hundreds. So what is 7 plus 5? That is 12 with 2 zeros behind it because it's in the third column. Then the next one, we have 6 plus 5. That makes it 11 with only 1 zero behind it because it's in the second column. It's in the tens column. And then we have the 8 plus 7, which is the 15. Now, one of the hardest things is going to be when you teach students how to write numbers, these kids, is because typically they're going to start wanting to left justify everything they write. Because they're going to write this number as what's wrong with that? Besides everything. Is this the hundreds column? No. Is this the tenth? No. So you have to be very careful on how these things are written. So it has to be right justified. The ones have to go in the one columns, tens, and the hundreds and the thousands. Then all you do here is just add the columns. 0 plus 5 is 5. 0 plus 1 is 2. 2 plus 1 is 3. And then the 1. So there's your final answer. That's left to right. What do you think right to left's going to do? Where do we start there? On the right-hand side. What is 8 plus 7? That's 15. Then we have in the tens column, we have 6 plus 5. Well, if you want to, you could put these in there. This is in the hundreds column. This is in the tens column. This is in the ones column. This tells you how many zeros to put behind it. 6 plus 5 is 11 with 1 0. So it's 0, 1, 1. Then 5 plus 7, it's in the hundredths column. So it's 1, 2 with 2 zeros. So what's the easiest way to make sure students put it in the right columns? Have them use columns. So 15, this is the ones, this is the tens. And it's also going to reinforce what it means by the place columns, placeholders, and the position number for the numbers. Add these all up, and you get the same answer. Should we ever get the different answer? No. Now, remember I just said earlier, is there more than one way to do an answer? We just proved it. So that's going to be one of the hardest things is teach the way that's easiest for the students to learn. But when you come and when you're observed by whoever it is in your school, make sure you teach the way that they want you to teach. Because they're getting paid by those people who wasted the money in the first place. So yeah, it's again, the bottom line that people forget is making the students learn. We should use this most simplest, easiest, direct way to teach students, not the way that these administrators think, hey, I saw this in a conference, I think it's cool. I don't have to use it, but I think you should. So it's so frustrating. Trust me, you're going to see this throughout your entire career. Every year, it'll be a different concept. Every year. Don't believe me? Ask some of your teacher friends. They'll say that we were supposed to use this, we're supposed to use this. And then at the end of that year, it gets thrown away, something new comes along. That's just total waste of money by the district. And so what do? They close schools down. As some of you all heard. All right, another method. The lattice algorithm. What? Okay, ever hear the word algorithm? What does it mean? You can't use the definition in a word. The word in a definition. What is algorithm? In computer engineering, in programming, it's a program. It's the plan you follow. Order of operations is an algorithm. It tells you what to do in which order. That's what an algorithm is. That's why they call it algorithmic processes. And that's the way when you teach math, you'll be doing it that way is what do you do first? What do you do second? What do you do third? That's an algorithm. It's a plan. This one's pretty cool. So let's use the same numbers. What were those? It was 568 plus 757. Now, in this answer column, Oops. Oh, crap. I'm sorry. I went too far. And so on and so forth. All right. The columns are still the same. Only thing different now is I put a diagonal line through it. Why is that diagonal there? 4. What is 8 plus 7? 1 plus 5. It's 15. What is 6 plus 5? 11. So it's the 10s go on top and the 1s go on the bottom. And then 7 plus 5 is 12. So what's the final answer here? Well, look at the columns. This one's 5. 1 plus 1 is 2. 1 plus 2 is 3, and then a 1. I know. First time I saw this, I thought that's pretty cool. Again, low stress, a lot lower stress than the past. You don't have to worry about carrying anything over. It does it automatically. Let's do another one. Let's do a bigger one. So the first thing you have to do is create your columns. What's the next step? So steps. Step 1. Place each value in columns. This is the ones column, the tens, the hundreds, and the thousands. Second, create individual columns with vertical lines. That's what we just did there. What's my third step? Place a diagonal line in the solutions row. So from top left to bottom right, top left to bottom right, top left to bottom right. Add each column of numbers. Place the tens number on top. Place the ones number on bottom. So 7 plus 8 is 15. So it's 1, 5. 6 plus 7, 13. 5 plus 6 is 11. 3 plus 5. So it's a 0, 8. Then step 5. The diagonals. going top left to bottom, top right to bottom left. So the first one is a 5. It just starts, this number, whatever's here, is always a 5. 1 plus 3 is 4. 1 plus 1 is 2. 1 plus 8 is 9, and then 0. So it's 9, 2, 4, 5. You notice about this process, there are really no numbers bigger than 9 that you have to deal with. Even when it's a 15, you've now separated them into two smaller numbers that are single digits. Pretty cool. Because typically the first way you'll teach them is by using the manipulative blocks, where you have to separate them, and if you need more, put it on one side. But again, that gets to be cumbersome. You'll see that because first off, you have to clean up. When you tell them to clean, put everything away, you're going to be missing, and then you'll clean up at the end of the day. You'll see cubes everywhere. So eventually, you'll try to get away from those cubes as much as possible, as fast as possible. So teach them something that first off builds their penmanship, as well as their strategies. All right, the next method, which we've already done already, is column addition. This column right there. So opposite change algorithm. Oh, by the way, remember we talked about algorithm earlier? There's your algorithm. Algorithm is a plan. It's step-by-step instructions on what to do. That's what whenever you hear the word algorithm, that's all it is. It tells you what do you do in step 1, step 2, step 3, step 4, step 5. Let's look at these numbers. What number we'll deal with? 189 plus 278. Let's write these two numbers like this first. So what the opposite change algorithm, here's a property we have to use first. If two numbers are equal, if A equals B, if I add 3 to A, what do I have to do to B to make it the same? I have to add 3 to B. Whatever you do to, okay, you call it the golden rule. Whatever you do to one side, do it to the other. But now what this means, if I move B over there, eventually you'll talk about addition and subtraction. If I move B on the other side, I have A minus B. A minus B is B minus B, right? If I take away B from A, I take away B from B. So what is B minus B? 0. If I start off with $10 and take away $10, I have no money. So now let's look what happens here. To keep this the same, if I add 3 to A, what do I have to do to B to keep it the same? Okay, if I add 3 to B, notice I put them in parentheses. Notice I put them in parentheses. This will be important because you'll see why. If I get rid of the parentheses, if I get rid of these, what do I have? I just have A plus 3. Oops, there should be a minus there, because that's a minus. Now, what do I do with this minus in front here? What's that called? What's that property called? Distributivity. Because yes, you're right. It means multiplication, but that's a property of distributivity. AX plus Y. Remember that? So whatever's in front. Is this a number? Yes. It's a -1. So it's a -1 times B makes it negative B. -1 times 3 is, well, negative times positive is negative. 1 times 3 is 3. Teach your students to use the signs and numbers separately. If they do that, the chances of them making a sign error during calculations will drop to practically 0. The less you have to worry about, the less chance of mistakes. The more things you worry about, the more chance of mistakes. So when you try to subtract the same number and same signs, it just gives too much work. Can I move things around? Yes. I have A minus B, and I can put the 3's together. +3 minus 3. So what have I just done is I've added 3 to one number and subtracted 3 from the other number. That's what this is about. Opposite change. So if I change one number positively, I have to do the negative to the other number. What do I mean there? So the objective here is to get to a number that's easy to work with. For example, 189. So the closest, what can we change? Let's worry about tens first. What do we have to do to change this to the next higher number? The next higher number is, if we add 1 to it, what do we get? 190. So if we added 1 there, we got to subtract 1 here. Now, what's another easy number? What's the easy number here? From here, if we added 10, what do we get? 200. So if we added 10 here, we subtract 10 there. That makes it 267. So now when we add them together, it's much easier. It's much easier because we don't have to worry about carrying over anything. So let's look at our original numbers. 568, 757. What do we do there? And you could change any one of the numbers.
To 568.
Yeah, add 2 to this one. What does that equal? 570. So we added 2, so we have to subtract 2. 755. Now what?
Add 30 to the 570.
And that makes it 600. So we subtract 30. So 5 minus 0 is 5. 5 minus 3 is 2. Now I've noticed these are all zeros, so I don't have to worry about anything. I just put 2, 5. 7 plus 6 is 13. That's the opposite change method. You could rewrite the numbers anyhow you want to make them easier. Any questions about those? So pick either of the numbers. Could we have done the same thing with this one? We could have added 3 and subtracted 3. And then that would have made 760. Then add 40, subtract 40. Like, it doesn't matter which one you do, it's going to be the same answer. Oh yeah. The scratch algorithm. What the scratch algorithm says is, the reason we call it that, let's say I have a number 2. And if I put a scratch through it, that scratch represents a 10. And then whatever number here I put on the bottom right, that's the remainder. That's the number I'm dealing with. I'll show you what that means in a second. So let's add these numbers. 87, 65, 49. Again, so all we do, we start off with this part up here. 7 plus 5 is what? 12. So that means I put a scratch through the 5. What does a scratch mean? A 10. And then we have 2 left over. So that's a 12. But I don't have to worry about carrying anything over. Now I continue from here. 2 plus 9 is what? 11. So I put a scratch through that one, and I have a 1. Since that's a 1, that's the only thing I gotta bring down. Now, what number do I bring to the very top of the next column? Count the scratches. 1, 2. So there's 2 scratches. And once you finish, the number of scratches carries over to the next column. Okay, here, start again. 2 plus 8 is what? 10. So I put a line through there, and it's a 0. 0 plus 6? 6. 6 plus 4? 10. So it's a scratch with a 0. So that 0 goes down. Whatever's that here, whatever's your leftover, that goes down. So what number gets carried forward? Yeah, 1, 2. So that gets carried forward. That's 201. Let's do another one. Let's add these numbers together. What's my first step? Look at the first 2 numbers in the ones column. 5 plus 9 is, so it's a scratch with a 4. 4 plus 8, scratch, make it a 2. So whatever's down here, that's the carryover. Since I have 2 scratches, I put that on top. 2 plus 3 is 5 plus 6. So that's a scratch, make it a 1. 1 plus 4 is 5. There's 1 scratch, so I carry that over. Then 1 plus 1 is 2. 2 plus 2 is 4. What do y'all think? Again, you've never seen these before. Would you count it wrong if a student used it? No, I'd give them extra points because that's pretty creative. Again, now, especially since we deal with the international world, different countries, different cultures teach math differently. So again, this whole concept of only one way of doing it is such a travesty of justice. Now, estimating solutions. it's very important to have an idea what the answer should look like. Is it within the range of what, once you finish all the work, does that look right or not? If I gave you 300 minus 15,000 and I said the answer is positive 645, would you say it's near right or very wrong? Why?
15,000 minus.
Because the 15,000, the negative number is a lot bigger than the positive, so it has to be negative. So that's the kind of stuff. You're exactly. So looking at them, yeah, it's like no duh. So that's what you're looking at, is look for patterns of these numbers. All right, now for these, the first method we're going to look at is adding from the left. It's not what you think. Remember, we're going to be adding these two numbers. It's not what you think of adding the 6 plus 3 and the 7 plus, no. What this is take this number and then add this number. What number is that? 30. 67 plus 30 is 97. And then add the 6. Take this number here, because this number here is 30 plus 6. I took this one because I know it looks like a 3, but it's in the tens column, so it's a 30. Okay, what we're trying to do here in estimation is just have a quick look at it. What's the fastest way we can come up with this number? So 7 plus 6 is 13. Carry the 1, 10. Here's another example. $36 plus 36. So we add what to the top one? And add this number. So we add a 30 is 66. Then what we're doing next is adding these two, really. Carry it over. 6 plus 6 is 12. Carry the 1, 7. Break up and bridge. Let's try the same one again. 67 plus 36. Breaking up. It's similar to what you did in the previous one. So the first thing you do, take the 30, you get 97. This 97 is added to that number. So 97 plus 6 is 103. So 7 plus 6 is 13. Carry the 1. The third method is trading off. Same numbers. 67 plus 36. By trading off, it's what we did earlier. Remember the opposite numbers? So if we add 3 here, what do we got to do here? Subtract 3. So that's 70 plus 33. Can we go further? We can even go further if we wanted to. We can take this number plus 30, make it 100, plus 3 is 103. Or you could do it right here. You can just go straight. 7 plus 3 is 10. Plus 30, so 70 plus 30. You could also do this one. So again, it's whatever path you want to go for it. Look at some examples here for the. Well, if I gave you a series of numbers. How would you add that together? That's one way. You can add up all the 5s, but there's an easier way. Grouping. Remember commutativity. By associativity, we can group them together how we want to. So if we add up 50 and 50, what do we get? 25 plus 75 is 100. 40 plus 60 is 100. So that takes care of all these numbers. So it's 1, 2, 3 plus 35. You can group the numbers however you want to, by whatever makes it easier for you. Any questions? That does it for section 2. Addition of whole numbers. Now we're going to do section 3.